Hello everyone. Today we'll be solving diameter of a binary tree. Alright. Just fix this. Okay. So first of all, let's try to understand the question. Diameter of a binary tree. We'll be given a root of a binary tree and we'll have to return the length of the diameter of the tree. So what does the diameter mean? It's the length of the longest path between any two nodes. And that path may or may not pass through the root node. Alright. Let's just consider a very small example. Alright. First of all, let's just try to see the tree here. What's the maximum length that you see here? It's between 2 and 4, clearly. So the length between 2 and 1 is 1 plus 1. 1 and 3 it's plus 1. 3 and 4 it's plus 1. Right, and just consider a small tree again. 2, 3, 4 maybe, and 0. Yeah. And yeah, let's just give it another node here. 5 and 6. Yes. So what's the maximum length here? If you'll try to pass through 0, it will take plus 1, and then 2 to 3, that's one and another one, and 3 to 6, that's another one. The length is 3. 3 bars, the length is 3, right? But that's not the diameter here. That's not the longest length. The longest length is between 6 and 5. How do we know that? Well, firstly, we know that from 2, if you consider 2, the longest length available in the left subtree is 2. Yes, it knows it. It knows that. And the longest length available in the right subtree is also 2. We know that as well. If we know that what's the longest length available in the left subtree and the right subtree, then we can know what's the longest possible path that will pass through this node, any node for that matter. If you know what's the longest path available in the left subtree for 1 in this case, and what's the longest path available in the rightmost tree, that's 2 in this case, you will know what's the longest path possible through this node. If you can compute it for every node possible in the tree, then you can also basically gather the information to tell what's the longest path that you ever find, because you'll try to find the answer for every single node, because when you will try to compute the length for any node, you will have to know the length for its subtree and for the other nodes that are the children nodes for this node, right? You'll have to find the answer for 4 to know the answer for 3, right? So that's the intuition as well behind this question. So now we have I think you must have understood the diameter of a tree. You must have understood the problem statement to this question and to the intuition. The intuition is this only, that you need to know the length, the longest length available in the left subtree and the right subtree, and you'll need to add 1 to it. Alright. Now let's just try to formalize the answer or the solution to this a bit more, so things may be more clear to you. So let's just take another tree, simple tree 1, As we know, we must know the length for each node, the possible answer that we can get for each node to know the actual answer, right? So, base case, firstly, you're on 2, right? You want to know what's the maximum possible length for 2. So, in this part, it's connected to null. In the right part, right subtree, it's null. So, null will return a 0, right? That's the base case here. And what's the maximum possible length we can get from 2? It's nothing. It's connected to nothing. So the max possible answer for 2, is 0. Yes, correct. For 1, let's just work with 5 first. Same thing. Right. 0, 0. Max for 5 is what? 0. Can't go anywhere with it. For 3, this side it's connected to null, so 0. But this side, it's connected to 5, right? So 5 the maximum possible length through 5 might be 0, but the maximum possible length it provides is not 0, it's 1, right? You will have to reach 5, and if you'll have to reach 5, a single step will mean you'll have a length of 1. So 5 will have to return plus 1, right? It will have to return plus 1. When it will try to process its subtrees, the maximum possible length it will be able to get ever in the below subtrees will be 0. But of course, the maximum length that it can give, it's more, right? It's a single unit plus 1, right? For 3, we know that it will have to go to the left subtree. It won't be able to get to the left subtree, but if it will keep traveling downwards, it will find 5, and that means the length that we need to get from the right subtree must be plus 1, because there's nothing behind or below 5 node, the 5th node, right? Okay, and so it will return plus 1. And when it will try to compute in 3, in this node, what's the maximum possible length for 3? Well, in the left subtree, it can't go anywhere. In the right subtree, it can go once, right? So that's it. It can go once. That's it. That's the maximum possible length here. So the max possible for 3 is 1. It will go up. But again, as someone will have to reach 3, the answer that it will have to return is, plus 1 of what it has already gotten. It has already gotten plus 1, because the maximum possible length you can reach from 3 is 5, and that's plus 1. The maximum possible 1 can reach for the right subtree, that will also be plus 1. So it will have to return 2 here. 3 will have to return 2 here, and 1 will have to return, and from here we will get 1 back. Same logic. To reach 2, you'll have to return plus 1, right? That's the length you'll have to return to reach the left subtree. Okay, and you'll jump, and that's the plus 1 here. You can also understand it in another way, that whatever length you get from 2, you'll have to add 1 to it, because you'll have to get to 2. That's another way to think about it. If that helps you, that's great. So now let's jump to the answer. Let's try to code this out. I'll just try to work on the answer now. Okay, so let's just, on every node we need to find the maximum value, right? So let's just try to find it. Let's just keep a global variable for it. It's to 0. And let's just keep another function for traversing this tree, pass route, return answer, because on every node we'll try to calculate what's the maximum possible length between any two nodes, right? any two leaf nodes, whatever the current node has children of, whatever possible leaf node it can get. What's the maximum possible length between the two deepest leaf nodes? Deepest is very important. We'll make this function not white because recursion will be involved here. We'll need length. We'll have to code out the base case. Whatever we are getting from the length we are getting from the left subtree, whatever length we are getting from the right subtree, answer will be the max of whatever answer we already have and left plus right. Correct? Because we are getting the deepest lengths, right? We are getting the deepest lengths. Whenever we call DFS root left, what we are telling is from the left subtree, return me the deepest length I can get, right? From the right subtree, return me the deepest length I can get. That's what we want from the DFS function, right? So if it's 1 here and 1 here, the answer is 2, correct? So 1 here and 1 here, the answer will be 2 for the node 2, all right? And what we try to return here is, let's just suppose you're on 4, so the left and right will be 0, of course. So what you will return? You will not return 0. You will return whatever is the max of left comma right. Whatever is max out of both, we'll return that one. So let's just suppose there was another node beneath 5, right? So what should be returned to 2 here? Deepest length, right? So plus 1 and plus 1. So to 5, 1 must be returned, and to 2, 2 must be returned by 5, the 5th node, the call we make for the right subtree for 2, correct? So that must be returned. Okay, must make sense. Let's just try to run it first. It's working. Yeah, good enough. You can see more optimized solutions as well, but this is the basis we have behind this question. Thank you. Please like and subscribe.